Formation of shadows. When there is some obstruction in the path of light, we see a shadow. Light is always needed for a shadow to form. Shadows can never form in total darkness. Let us see how a shadow is formed. If an opaque body is placed in the path of light, the light cannot pass through it. The rays are stopped from going to the other side of the opaque body, and the space behind the body does not receive any light from the source. The space behind the opaque object where the light cannot reach is called a shadow. Thus, shadows are formed when light is stopped by objects. An opaque object casts a dark shadow. A translucent object casts a faint shadow. And a transparent object casts no shadow at all. Shadows are formed because light travels in straight lines. If the source of light is very small, that is, a point source, then a sharp, well-defined image is formed on the screen. When the source of light is wide, two shadows can be seen. One shadow is completely dark, called the umbra, in the center, and the other is a partial shadow, called penumbra, surrounding it. Notice that the umbra does not receive any light from any portion of the source, whereas the penumbra receives light from a part of the source. Shadowless lighting. The fact that light travels in straight lines and produces shadow is used to produce shadowless lighting. Here, the source of light is much larger than the object. For example, when a fluorescent lamp or a row of bulb is shown on an object, the umbra formed is very close to the object. Thus, by reducing the umbra region of the shadow, a shadowless effect is created.
This one is the light source, this one is the object, and this one is the screen. Now, when the object is nearer to the light source, the shadow will become larger. If the object is further away from the light source, the shadow will become smaller. One way to remember is light. Start with L. L stands for large. So when an object goes nearer to light, which is L, the shadow will be large. When it's away from the light source, the shadow will be small. Now this is screen. Start with S. S stands for small. If the object goes nearer to the screen, the shadow will become smaller. Now, there's another way that we can do that. If the torch, which is the light source, go nearer to the object again, the shadow will become bigger. When it's further away from an object, the shadow will become smaller. Same for the screen. When the screen is nearer, screen stands for small, right? When the screen is nearer to the object, the shadow becomes smaller. And when the screen is away from the object, the shadow becomes bigger, right? So we can shift either the torch nearer to the object, bigger, further away from the object, become smaller, right? When this one goes nearer, to the screen, as it goes nearer to the screen, screen stands for small, you become smaller shadow. And when it's away from the screen, then the shadow become big. And if you shift the screen nearer to the object, the shadow will be small. Further away from the object, the shadow will be big. So again, whenever the object is near the screen, when they get nearer and nearer, the shadow becomes smaller and smaller. When an object gets nearer to the light source, the shadow will get bigger and bigger.